Hi everyone, good afternoon and welcome to this seminar where we have Dr. Sally Potter, who's come to talk to us about the future of forecasts and warnings. And of course this is a really important subject when we're thinking about warnings as to where they're going to go, what's the next step and how can we enhance them. So we're really delighted that Sally's joining us from New Zealand to come and talk to us today. So Sally is a senior social scientist at GNS Science in New Zealand, and she conducts research on the effectiveness of warnings and forecasts across all hazards, including impact-based warnings, risk perceptions, and behavioural responses. She's then quite unique because she applies these results to try and improve warnings in practice, and this includes communication products and scientific advice as well. She's also the co-chair of the World Meteorological Organization's worldwide WWRP. What does that stand for, Sally?
World Weather Research Program.
World Weather Research Program. There we go. High Impact Weather Project. So many acronyms that we have across the hazard world. And Sally is located in the Emergency Management Bay of Plenty, in the Bay of Plenty in Tauranga in New Zealand. So we're really delighted that she's here to join us here at the Warning Research Centre. And as you are, I'm sure, all are well aware, that at the Warning Research Centre, what we're trying to do here is to bring people together from different backgrounds, different disciplines, different geographies and different hazards to try and share their knowledge and see where we can find some synergies and learn and understand how we can enhance our warnings going forward. So I'm the chair for today, so my name is Carina Fearnley and I'm the director of the Warning Research Centre. So it is with great pleasure that I would like to pass over now to Dr. Potter, who will give us her talk.
Great, thanks very much, Carina. Okay, thanks very much everyone for coming along today and for joining online. It's an absolute pleasure to be over here and able to talk to you. So thanks very much, Carina, for organising this event and for giving me this opportunity. So as Carina said, I'm a social scientist in Aotearoa, New Zealand at GNS Science. GNS Science is our Crown Research Institute, or our government sort of funded and the official voice for geohazards in New Zealand. I'm based in Tauranga, which is a regional town or city in the North Island of New Zealand, and the rest of my team and department is spread out across New Zealand, mainly in the Wellington and Auckland areas. So I'm sure you're all very aware that we've got this initiative by the United Nations to have early warning systems for all people within the next 5 years. There's a whole lot of guidance and information and reports and documents that are available to give people this guidance and practical information about how we should be doing this. So what are we doing in the research world to look at, to provide this evidence base for all of this kind of guidance that's going forward? I want to provide a bit of a scenario here, a forecast, if you will, about what forecasts and warnings might be like in the future. Now, how far in the future that is, I don't know. When I initially was thinking this up, it was probably 30 years away or something like that. Over the months since, honestly, it's becoming a couple of years now. The amount of progress that AI and technology is improving and advancing is quite scary. And so I wanted to try and think, how could this be applied to warnings? So let's say you're sitting in your kitchen and you receive an alert, probably on your cell phone, or if it's in the future, it might be some other sort of device that says, warning, landslides may cut off access to your house on Wednesday. So it's in a couple of days' time. It suggests that you self-evacuate tomorrow or prepare to be isolated for several weeks, as there are likely to be many landslides blocking the access road to your house caused by a cyclone that's on its way. And then provides a few suggestions, links to help you decide what you want to do. One might be, do you want to book a hotel that would be affordable and in the area that you wanted to go to, because it just knows these things. It might say, do you want to order these particular supplies, because it knows from your fridge how much you've got and what you're going to need. And maybe it will ask if it wants to block out your calendar in a couple of days, because it knows that you've got children at a school that's going to be shut because of the landslides and the cyclone that's going to come, right? So we've got lots of things underpinning this kind of message. It may provide also a link to augmented reality, so you can have a look and see out your window what it will look like if we've got a cyclone coming through, or what these landslides might look like. So the question here is, who sent this warning? How did they know what that hazard is going to be like in your location and what you might personally need to be able to do in order to mitigate the effects? And yeah, basically, how does it know all these things? And who's in charge here? Who's the responsible agency or company that is sending that warning? So what I'm suggesting is we may need this whole new paradigm for warnings. So instead of an official agency deciding what the threshold is, when to issue that warning, and doing so in a fairly generic way to a whole community or region or even country in some contexts, instead maybe those warnings are automatically triggered on an individual level, and that's based on probabilistic spatial hazard information and forecasts. It could utilize our digital footprints, and then it might suggest this tailored mitigation actions. So how do we as science agencies and also as warning researchers, how do we fit into this kind of future scenario? My talk is basically broken into three main themes. The first is the multi-hazard forecasts, in which we'd need probabilistic spatial information. And I'm going to give an example on what we're doing at GNS for this. Impact forecasts and how we might use big data and artificial intelligence or AI and how we can potentially make these dynamic, and if we should. And people-centered, so how and should we be giving tailored mitigation advice, and how do we know what sort of guidance options we should be providing? So looking first at the multi-hazard forecasts, I think that hopefully fairly obviously we need to continue our monitoring. This is fundamental to being able to give forecasts. But perhaps we can increase the amount of data that we're collecting for that monitoring from more alternative sources. So perhaps some more citizen science crowdsourcing. Now in New Zealand, we are starting to do this at GNS Science, where we're putting out, it's basically a survey that's available all the time on the GeoNet website. That's our monitoring program, that people can contribute what their observations are for hazards and impacts, so that we as scientists know when something might be happening that our monitoring equipment did not pick up. So this can be done for volcanoes, landslides, earthquakes, and tsunami is our aim. We're getting there. We may also be able to start to gather together the smart city data, new technology, more satellite imagery and drones, and you know, even dash cameras, and all sorts of different ways that we can collect information and sensors, either from people or from the technology itself, to contribute and help with our situational awareness. Of course, I think we need to have continuing underpinning research. We need to continue advancing our models and our forecasts and nowcasts. And we need to consider, do we need to go to higher resolution for these kind of hazard forecasts? So these hazard forecasts need to be probabilistic and spatial. And the reason that I think that that should happen is so that we can overlay that with people's individual risk thresholds, their risk tolerance thresholds. And that way we can look at giving them a tailored warning, a tailored specific warning. But it's still a question as whether we should do that. Is that a good idea or not? We also need to consider how will AI change our model and forecast development. So as scientists making physical hazard forecasts, please think about what can AI do to help advance your forecast. It's there, it's available, it's increasing and advancing at a rapid pace. There should be specialists in AI that can pull together all this information and rapidly advance these forecasts. So let's look at our example now. So GNS Science, as I was saying, we've got the mandate to provide geohazard science advice to our stakeholders, government, and also to the public of New Zealand. Our GeoNet monitoring program looks at all of our geohazards. There's other agencies for the meteorological and hydrological hazards. And we have a 24/7 monitoring centre called the National Geohazard Monitoring Centre at GNS Science. And that was basically established to give more, being able to provide quicker science advice for tsunami in particular, for tsunami warnings, and also to give more accurate earthquake information as soon as they occur, as well as for our other hazards. So let's look at how GNS Science is currently producing hazard forecasts. And I'm going to use an example that's very close to my heart, This is for Taupō caldera volcano. So for those who don't know, Taupō is in the centre of the North Island of New Zealand, and it's now filled by a beautiful lake. And you can see the red dots on the map there are all the vent locations of previous eruptions. And you can see that they're quite scattered, and it's going to be very hard for us to know when it next erupts where exactly it's going to come from in this very large lake. Now in May of last year, 2022, we started getting a few more earthquakes than usual. There also seemed to be a little bit of uplift, which takes quite a long time to be able to see on the monitoring equipment. So after a little while, we were thinking, okay, is this unrest or not? It's very hard to know in a caldera. You can see in the left-hand figure on the top there, the scattering of the earthquakes. On the right-hand side, you can see where we started. By the end of the year, we got quite a lot of earthquakes compared to previous episodes in the last decade or so. That was a lot to do with the magnitude 5.7 earthquake we had at the very end of November, and its aftershock sequence really boosted those numbers up. And then we had uplift. It's been going up at about 60 millimeters per year. And then in that earthquake, we had quite a big jump more than that. And then it has continued since then. So to determine whether or not that was unrest, we used the catalogue that I produced during my PhD on the historical unrest episodes at Taupō, which had come up with this graphic basically to show the intensity of unrest that has occurred. So you can see that we've had quite a few minor unrest episodes before, and only 4 moderate unrest, and we've had no heightened unrest. And if anyone's interested, that uses the volcanic unrest index that I also created during my PhD to be able to categorize those unrest episode intensities. So we were able to compare the amount of unrest that was occurring with what had happened in the past, and that helped inform the intensity of the unrest that was occurring in 2022. So in September, we decided it was indeed unrest, which means we changed the alert level from 0 or no volcanic unrest up to 1 minor volcanic unrest. Now that hadn't happened before for Taupō or for any of our caldera volcanoes in New Zealand. And so it was a big deal, and we were quite worried that there was going to be a lot of repercussions to do with the economy, public perception, and basically would people get really worried about this and cause more adverse reactions than the volcano itself, which really is just having, some earthquakes that only some of them were noticeable. So what we did was a very careful communication campaign, basically, to give people information about what the volcano was doing, what it had done in the past. So we had this information on our website. We put out volcanic activity bulletins, which you can see publicly available on our website, and we had the information in there about what it was doing. We provided a fact sheet about Taupō volcano, gave it a bit of a spruce up right before it went out to make sure it was up to date. We gave video updates on the website and YouTube and social media as well, and basically as much as we could, and it was quite intense, and that was in September last year. We also made a 3-page stakeholder fact sheet to make sure that our stakeholders, so emergency management mainly, also iwi, our local Indigenous communities, and the government, they were all very aware about what unrest means at a giant volcano like this. So we had all that information in these fact sheets here that we gave them. We also provided links to reports and things on caldera unrest that we had written, over the last decade. Now, all of that information was essentially what is happening now in general. What is caldera unrest? How does it compare to the past? So now we get to the bit about the forecast for this, this volcanic situation. So what we did was combine what we were seeing with the monitoring information to what had happened in the past to produce these forecasts. We gave this scenario table to our stakeholders. You can see there are 6 scenarios in there. A, B, and C relate to unrest. So we went from a current state of minor volcanic unrest. Scenario A is that minor unrest will decrease back to no unrest in the next 3 months. B was that it will continue. C was that it will increase in intensity to still be an unrest, but a more heightened unrest. And then D, E, and F were for a small, moderate, and major eruption to occur within the next 3 months. Now, the unrest episode forecasts were based on my historical catalogue, and then Mark Bebbington from Mass University did some Markov chain modelling to get the probabilistic forecast. And then D, E, and F were based on the geological record on how likely it would be for these eruptions. So this really helped to show that while we were in unrest, the chances of going into an eruption anytime soon were actually still very low. You can see that there's a huge range in the uncertainty of those unrest forecasts, but the stakeholders still found them useful, they said. The other information in there are some examples, so historical or with the eruptions from the geological record, to give examples and descriptions of what it might look like, and along with those potential hazards there. So we updated these on a 3-monthly basis with very little change, because the monitoring was basically saying the same sort of thing, and of course the historical and geological history information didn't change. Another way we communicated those forecasts was a spatial figure kind of way that my colleague Danielle Charlton did a really good job on, and it just sort of shows that spread of uncertainty and how much more likely it is that that unrest was going to continue without progressing towards an eruption. So we got good feedback on that one as well. We gave it spatially as best as we could in a very short time, because of course we didn't know when the alert level was going to change and when all this information had to go out. So we had to do a lot of work in a short amount of time here. But we showed if there was to be an eruption, so that was scenarios D, E, and F, what it would look like for small, medium, and large. So you can see the near event hazards on the left side, and then the probabilistic ash fall according to predominant wind directions from Simon Barker from Victoria University's paper on the right there. So a lot of this work and advice was produced along with the New Zealand Volcanic Science Advisory Panel. So while GNS has the monitoring equipment and expertise in-house, we also reached out to all the universities basically in New Zealand who have any kind of knowledge and expertise about Taupō, and Victoria University and Massey were particularly very helpful in determining this kind of information, and worked together to help us with our science advice out to the government. So that's the end of that example now. So let's look at why hazard forecasts and warnings need to be multi-hazard. So it's in the Sendai framework for disaster risk reduction under target G that we need to increase our ability to produce these multi-hazard early warning systems. So what is a multi-hazard early warning system? This is a warning system that's able to cope basically with either hazards that might occur in the same place completely separately. So you might have a location that's susceptible to flooding and volcanoes and fire, or that are linked together through cascading hazards. So for example, having a large earthquake causing a tsunami, which can then affect the houses on shore in different ways, but at the same time or very close together. So obviously this is a bit of a challenge for a warning system and for risk modelling in general. So if we're going to try and integrate these warnings for these different hazards, where should we do this? Which sounds like it should be obvious, but when you're actually doing it and you're practically trying to achieve this, how do you do it? Is it within the science agency? Because we have often a geohazard agency and then also meteorological and hydrological agencies, which might be separate as well. So, you know, literally, where do these models get integrated? Is it perhaps with the emergency management agency or in the government somehow? Do they do it? But then they don't necessarily have that scientific information and the models and those sort of things either. Is it in insurance companies? Because they tend to integrate the models, but then they also have more of a longer term focus, and it's not so much to do with warnings. Is it perhaps in these tech giants, the likes of Google, Amazon, Meta, Apple, Microsoft? Because they've got the technological know-how, they could perhaps integrate them for us. Or is it perhaps in private enterprises, but they're going to have different drivers to us who are trying to give public warnings. So let's look now at impact forecasts. And the picture that's shown here is from a flooding event that occurred earlier this year, just a couple of months ago, that really was hard hitting in some parts of the North Island of New Zealand. So in terms of terminology, the foundation of warnings, you'll hear a lot of different terms and ways of talking about the foundation of warnings. So I'll just go through what I understand them to be. The first is a phenomenon-based warning. So this is the more traditional based warning, where warnings are triggered on the threshold when the hazard gets to a certain level. And the example there would be that you're expecting 150 millimeters of rainfall in an area over 18 hours tomorrow, for example. Now that takes into account hazard and hazard likelihood. If you then include the vulnerability and to some extent the exposure of people or assets such as buildings and infrastructure, you might get to an impact-based warning. So this is when your threshold is based on the amount of impact that you are expecting in that area. The example here is that the rain that's expecting to fall is likely to cause disruptions to travel in the certain area tomorrow. If you take into account exposure to more resolution, basically, and you can be a little bit more specific, so for example, taking into account that it's rush hour and you've got more cars on the road, then you've got the impact warning. And the warning itself might look like expect congestion and train cancellations in your particular city tomorrow during rush hour due to the flooding caused by the heavy rainfall. And then you've got the call to action warning when you take into account people's behaviour. And that's when the trigger for your warning is based on the action that you want to happen. So this is perhaps stay at home tomorrow because of the congestion and the delays and the flooding and the rainfall. There's also the impact-oriented warning. This is what Rainer Kaltenberger published in 2020, where the warning itself, it doesn't matter what the threshold is. It could be based on hazard or impact, but the warning content includes the impact advice and the advice on what you should do as well. So that's a little more generic, and it's quite helpful because I think there's a lot of confusion in the kind of weather warning world and other warning sort of situations where people throw around impact-based warnings without realizing that you're actually talking about the threshold in which you're warning, not just the content of the warning itself. So I urge people to be conscious when they're using these terms to understand what they mean. And perhaps, to be honest, it should be just a risk-based warning because these are the elements of risk anyway. So I think that's something that needs to be discussed in more detail. So how are these impact-based forecasts and warnings made? I had a very good PhD student, Sarah Harrison, come and look at what the data is that informs impact-based warnings. She produced, I think, 5 papers on this, and she's found that you need to have the hazard, impact, vulnerability, and exposure data coming together to inform impact-based warnings. The way that you can do that is either having a modelling approach, kind of quantitative, objective, using perhaps risk models, or you can have a more impact-oriented discussion approach, more subjective. Basically, you might have your weather forecast, and then they just know or can talk to the right people to go, yeah, okay, that's going to be quite impactful. Perhaps you use a risk matrix and give out a red warning, for example, based on that, rather than using an actual risk model. So I encourage you to go and look up Sarah's papers if you want to know more information about the underpinning data needs and where we can get that from. And basically the take-home point here is that there is a lot of data out there that can inform impact-based warnings. It's already there in many countries, and the secret is trying to connect it together and have access to it to inform the warnings. How can big data like digital footprints and artificial intelligence help to inform particularly the vulnerability and exposure data of individuals? That's something that we need to look at. Can we get hold of digital footprints? Should we get hold of them to inform this kind of dynamic underpinning data? Because that way your risk model is not just telling you what in general should be the warning that's given for a particular event, but at what time of the day, how is people movement changing? How is vulnerability changing, if at all? And then how does that affect warnings? There's a lot going on in that space at the moment. So I've had a lot of scientists say to me, I gave a really good warning. Why do people not respond to it? Well, there are a lot of reasons, and they're quite nicely summarized by Lindell and Perry's protective action decision model, which is shown here. There are a lot of things that go into a person's brain and consciousness before they decide to respond. So the first thing on the left-hand side is environmental cues. So this is how much they look out the window and see storm clouds gathering, Or if you're on the beach and you see the water receding, like, are they noticing this sort of environmental cues, and how well does that match up to your understanding about what a hazard does as a natural warning? Social cues are things like whether you can see your neighbour packing up their car to evacuate, or phone calls from family and friends, for example, and just social media, you know, seeing what other people are doing, or whether the council has provided buses to evacuate, all these sort of social cues there. Information sources and channel access and preference relate to what sort of devices are you plugged into? Do you watch the news at night and that's it for the day, or do you have push notifications on your phone? How much information do those provide? Is it just a national radio station that's not going to be able to provide detailed information for you? Or is it a targeted push notification that's got your settings in it, for example, and it knows exactly what you need and when? The warning message itself is an influence. And of course, that's where a lot of our research as warning researchers plugs into that bit there. How can we improve our warnings to make sure people have the best chance possible of responding in an appropriate way? And then we've got the received characteristics. That's things like demographics, socioeconomic information, their language preference. A lot of things go into that as well. So with all of that taken into account, you then have the pre-decision processes. So that's if you've got an alert coming, say it was coming to your phone on the emergency mobile alerts, the cellular broadcast like you guys have just got in the UK, how exposed are you? So do you actually receive it? And do you pay attention to it? So you might be mowing the lawns with your earmuffs on and you didn't even pay any attention to it, or you didn't hear it in the first place. And then comprehension. So how well did you understand it? Is it in the language that you speak, or is it full of jargon and acronyms that you couldn't understand? So once all of that's taken place, you've received it, you've understood it, it then takes into account your threat perceptions. So how threatened do you think you are by that particular hazard? And I think that it affects all of us, right? When we get a weather warning, it happens all the time. You're like, oh, I'll be all right, it'll be fine. It's only 120 km/h wind gusts, or it's only that much rainfall. I think I know what that means. So it depends how threatened you feel and what your plans are for the day as to how that might affect you. And that takes into account things like your proximity to the hazard. So if it's a tsunami warning and you're up on a hill, you're like, I'll be fine. Or river flooding, same sort of thing. If you're not near a river, that, you know, then you don't think that you're threatened at all. And that also takes into account then your prior experience as well. That's where that one sits. Protective action perceptions. This is if there's information in the warning message that says go and clear your gutters, how effective do you think that's going to be for you to actually reduce the risk? And stakeholder perceptions is how much do you trust the stakeholders? Usually it's the government. Would you ever listen to a message from the government, etc. So then with all that in, you decide you're threatened and you know what you're going to do. You can take that decision and you might have a behavioural response, which could be to go back and look for more information. It could be doing a response, or it could be emotion-focused coping. And you can then have impediments or facilitators. So an impediment would be you go to evacuate, but the road's blocked by flooding, or a tree down, or whatever, or a landslide. And the facilitator might be you actually don't have a car and you can't evacuate, but somebody drops by to pick you up and helps you along the way, or the council provides a bus, etc. So in order to know how effective a warning is, we need to take into account that warning message and people's comprehension of it, what their perceptions are, and what their actions are. Because at the end of the day, we think a warning is effective if their behavioural response has been appropriate. So those are the bits that we're going to measure to know, are impact-based warnings and other types of warnings effective or not. So I've split these out, it's 2 slides. One's on the perceptions and the other one's on the actions. So the first one, how effective are impact-based warnings on influencing people's perceptions? So a paper that I wrote in 28 for the team looked at the effectiveness of impact-based warnings in New Zealand using a hypothetical scenario. So half the population, or the sample population, got a message that was hazard-based, traditional, showed 140 km/h wind gusts coming, and the other one got more impact content in the message. And then I used statistical methods to understand what their perceptions and actions were. So you can see that's the one in red. And then I've compared that to some of the other literature out there to see how it compared there. So good news for impact-based warnings in terms of effectiveness is that it does increase people's perceptions in terms of threat, concern, and their understanding of the potential impacts in comparison to traditional hazard-based warnings. And most of the research out there agrees with that. It doesn't affect the credibility of the message too much. There is one paper out there by Perrault et al. That was saying that impact-based warnings were detrimental to credibility, but actually a couple of us have found there's not too much of an impact there. And now in terms of actions, however, the picture is not so rosy. We've got half the papers saying that impact-based warnings are a positive influence and it does increase people's actions. And the other half, including mine, was that there was no significant difference at all. Now, this is quite worrying when we've got a lot of efforts going around the world to moving towards impact-based warnings. So it's probably that there's a lot of other things that are more influential than this particular type of warning message. So things like people's prior experience, their gender, age, perceived exposure to the threat, and their plans. So again, could we use big data to help include those demographic factors that are on our digital footprints to improve our warnings and design? Now, this research, a lot of it's hypothetical and not real event situations. It's very difficult to do a real event, which I have recently found, when everybody is receiving so much information from all different types, from different sources containing different things. It's very hard to do a cut and dry experiment using real information. But maybe the result's quite different if your target audience is not the public, but the stakeholders. So I think there's potentially impact-based warnings are very useful for stakeholder audiences, emergency services, emergency management, etc. So if science agencies like the Met Office, Met Service, etc., or GNS Science and other geohazard agencies, if we're giving our information to the emergency managers to then pass on in whichever way they think is appropriate, maybe that's good. But I think we need to test that a little bit more, because at the moment it's not cut and dry. So I've got an example here on how GNS Science is producing impact forecasts. What we did is during Cyclone Gabrielle, I showed you the image before of the flooded town. During that event, we put out a landslide forecast. This was using the NIWA, National Institute for Water and Atmosphere, so that's like our equivalent, but for hydrometeorological hazards. They gave us their weather and forecast information. We ran our landslide forecast information, which is that image showing there. And then we used our risk model, which is called RiskScape. This overlays the hazard, exposure, and vulnerability layers to produce the impacts that are likely from that particular scenario. And that produces the impact forecast. So this one here was the impact on the road, the number of landslides per kilometre on the state highways from this particular event. And we did give this out to the stakeholders in these affected areas prior to the event happening. And then we also did it on the number of residential properties per ward that were likely to be affected by landslides as well. And you can see there just north of Auckland would be hard hit, and they indeed were. So it was promising. It's very much a trial product. And our next step is to, after I've got high risk ethics sorted, go to the stakeholders and get some more feedback on what they thought of these, how did they use them, what can we do to improve them. Now, under the World Meteorological Organization's World Weather Research Program, High Impact Weather Program, we have a working group on impact-based forecasts and warnings. So our aim is to understand where are the research gaps relating to impact-based warnings to try and guide some global research on this over the next few years. So first of all, we did a literature review to see what gaps were already out there. We held an international virtual workshop series last year, and then we're collating all of that information at the moment to produce some written outputs. And we're doing this in coordination with the WMO expert team on impact-based warnings, which produced the guidance that's out there already. So the 3 workshops were based on underpinning data and model integration, on people-centered impact-based warnings, and on multi-hazard impact-based warnings. We had over 330 people joining from worldwide. So a few weeks ago, we met in Exeter at the Met Office and started to write up those findings, and we're hoping to get them published over the next few months. So if anyone joining here today was at that workshop, just want to say thank you very much for your assistance and involvement in that initiative. I think it's showing some really good promise to where we can go and what sort of solutions are already out there as well. So finally, looking at people-centered forecasts and warnings. The first thing here is whether we should be producing tailored warnings. So this is when a warning is given out that might affect a whole community. Can we make those warning messages and perhaps the thresholds more tailored to individual needs? So, you know, would the messaging to one person be different to the neighbour because the neighbour does not have children, or because they've got a stronger house, for example, and maybe just their risk tolerance thresholds are different as well. Now that has implications on the resolution needed for our modelling. So there's a big driver with our hazard forecasts in particular in our models to get higher and higher resolution forecasts, and it's probably needed, you know, particularly for things like weather forecasts. It's really good to know if your high intensity rainfall is going in one catchment or another catchment, for example, because that has implications on which valley should be evacuated. But what is the resolution that is needed for the vulnerability and exposure in the models? Do we need to try and get higher and more dynamic data for vulnerability and exposure, or is it okay to have fairly general? And I say that because even if you knew that one particular, like the suburbs of a city were relatively empty during the day because everyone's in the city, would you still warn that area? Would you change the threshold in which that area is warned just because there's less people? But there's still people there, so you know, surely they should receive a warning as well because they are going to be impacted. So for me, this is a fundamental question and a research gap that we need to be looking into. Are these tailored and highly specific impact-based warnings in particular, are they good, or are they empowering people, or are they actually disempowering people? Who are these warnings aimed at? Is it stakeholders and community or regional level, or is it for individuals? And my vote, of course, is for individuals, because we're trying to empower individual people to act in the best way possible. Now, in terms of cultures and Indigenous knowledge, could we or should we be trying to access information and knowledge about what they think is important, or should we not? It's in a lot of cultures, it's their knowledge, and we shouldn't. It's not our role to be taking on that knowledge. So it's working with these communities to understand what's appropriate there. How can we get better two-way communication? So a lot of the time, science agencies, we're pushing information out. How can we better listen and get local knowledge back through community liaison and participatory kind of approaches? Crowdsourcing is one way to do that, of course. We need to look more into what appropriate behavioural responses are, because in a lot of cases, such as multi-hazard situations, the advice for one hazard is not the appropriate advice for the other hazard that's occurring. The example being a flash flood, don't go down into low areas, but for a tornado, maybe you are supposed to be sheltering in a low area. And so fundamentally, we need the partnerships and the collaboration across all of these different aspects to bring all these things together and make sure it's being done in a strategic way. And it's not just one agency deciding, oh yeah, we're going to do impact-based warnings, you know, and then not realizing that another agency down the road is already doing it, or in a slightly different way, in a different resolution with a different audience, using different data, etc. So having some oversight and strategic direction is definitely needed from a government level. So we know that actionable guidance is more effective if it's meaningful, targeted, and easy for people to do. That's fundamental. But we've got increasingly diverse audiences. So how are we meant to, as a government agency, provide that kind of detailed information? Now, the Early Warnings for All Executive Action Plan does indicate that AI can support scalable warnings. So can we use digital footprints to understand what people's individual needs are, and should we? If you think about it, out there in the big wide world, we've got a lot of our digital data just circling around. I don't know where, somewhere up in the cloud. We've got things like purchase history, right? So if we think about in a COVID situation, it, somewhere out there, will know how many masks have you purchased? Do you wear them, from the facial recognition sort of information that's out there? What sort of things do you like to buy? What sort of places do you go to? Do you go to a crowded nightclub, or do you prefer to sit at a cafe which has an open air terrace? You know, what are your risk tolerance thresholds from this? What did you say on social media, and how often are you on there? What have you searched for on the internet? What are you left leaning? Are you right leaning? How much do you trust the government? Where do you get your news from? Hopefully it can't access our health data, but you never know. We've got voice recognition as well, our lifestyle data, what sort of things do we do? And then in the top right corner, we've got the less invasive approach. Perhaps we can get this information through structured surveys. So have those kind of risk tolerance information and exposure and vulnerability surveys out there, and people can voluntarily input their data to that and say, here's when I want to be warned, rather than relying on all the data that's out there. Controversial, eh? So who's heard of ChatGPT? Who's played with it? Yeah, it's good fun, eh? So this is a large language model that uses open access, OpenAI, to produce text, right? You can have a conversation with it, and it's great. If you haven't tried it, I highly recommend it. It's really good fun. And so I thought, well, can it produce targeted warnings? Let's give it a go. So I put in it to ask, what should the warning message be for a cyclone that's coming for a male with no children who's got a dog and he works from home? The next slide is going to be for a female with 2 children who commutes to work, okay? And the differences are in red. So, attention, a severe cyclone is forecasted to hit your area in the next few days, bringing strong winds and heavy rainfall. As a resident who works from home and has a dog, that's basically cut and pasted from what I put in, we urge you to take precautions to ensure your safety and that of your pet. Make sure to secure any loose objects around your property, stock up on necessary supplies like food, water, and medications, and prepare for potential power outages. I don't know why the female didn't get that information, to be honest. The cyclone could cause flooding and landslides, so be cautious and avoid any unnecessary travel. Stay updated with the latest weather reports and follow any official advice given by the authorities. Stay safe. Okay, so altogether, not too bad, I have to say. You know, if this was what was going to go out, it does a lot of the job for us. Now, the second one, as I said, is for the female. So the difference here is that cut and paste kind of working mother with 2 children, ensuring the safety of your family instead of your dog. Prepare an emergency kit. I didn't get that information. Stay indoors if conditions worsen. So all in all, it's pretty similar, but it does give that slightly more targeted and tailored advice. And this is the short version. Like, it really did spit out very long, detailed information. And there was another one that I was playing with as well that was giving incredible advice. I was playing around with a building a house that met the building standard for a cyclone that was coming, and one that didn't. It was a leaky building. It was not going to be so good. And the differences in targeted advice was quite incredible. It was saying, you know, your building probably hasn't got much of a chance, do this, do that, and the other to prepare for it, evacuate, you know. And the other one was like, you'll probably be okay, just check your gutters. And it was quite incredible, and I think there's a lot of promise there that we should be looking into. So if we had decentralized warnings, what would be the role of science agencies in emergency management? So if you can imagine being that person sitting at home and receiving that forecast, that warning on your phone, you might be getting that information from a bunch of different sources. You could get it from emergency management or from the government science agencies if it's their role to give you that warning. You also might get the warnings from the roading network, you know, like the highway company, whatever it's called in your country, and the telecommunications companies, rail networks, a whole lot of different agencies are already starting to do that, providing the warnings about the event and the impacts and how it's going to affect you and your commute and your power. Then we might get it from our tech companies, right? If you think about Google, it's already producing earthquake early warnings. It can come into your country and it can produce these automated early warnings right to your phone, whether your government likes it or not. And so I think it's happening already. You'd also get that information as per now from family and friends, social media, and more these social media influencers, the news media, private businesses, like private weather companies, for example. There's not just one anymore, there's a lot. You've got these different global models and forecasts, so like the Pacific Tsunami Warning Centre versus the New Zealand one, and that sort of scale side of things. And research institutes, universities, more and more coming up with these new ways of warning, new technology, and giving it a go as well. So that person in the middle is receiving a whole bunch of different information at different times and saying different things. So how are you supposed to process that? Should we let this kind of future scenario happen? Can we actually stop it from happening? And moreover, how can we be prepared? So as a science agency or as a warning researcher, what can we do to look into this and try and make the best situation possible? Of course, there are a lot of implications about this kind of future scenario. As I just said, we can get them from multiple sources, and so we'll have to look at warning fatigue and information overload. Commercial gain could drive the advice. So, you could be a hotel that's going, oh, I could do with a bit more business. Maybe I'll try and get people to come and stay here because there might be an event that's going to occur and it could affect them, etc. But also from Amazon and other big companies that want you to buy things. As we know, there are a lot of biases involved with AI in terms of algorithmic and societal biases. So that's definitely something that needs to be looked into, particularly with a warning lens. Now, you might have noticed that a lot of my talk has used AI-generated images from Delhi. I had Taupō erupting, Rotorua erupting, Auckland ashfall occurring. This is our hypothetical hurricane. We're going to get more and more of these kind of images out there. And as a science agency processing this information, or as an emergency manager, you have to figure out what's real and what's not. Situational awareness is really critical when you're rapidly trying to figure out if something's happening. You would probably know if a hurricane or cyclone was on its way anyway. But if you think about things like a tsunami, it could have occurred from a localized landslide that occurred that caused a big tsunami on a small little town that was away from sensors, and we wouldn't know about it. And so having these images suddenly come up online, you'd be like, oh, did that happen or not? So we're going to have to be really careful about how to cope with misinformation and have an increased lens on verification. So are we going to need maybe trained observers, like you can do with tornadoes, for example? I know the States have got quite a lot of them. Can we use smart city sensors to try and verify and look at this, increase our situational awareness? So if you're listening to this talk and you're very concerned about our privacy, I mean, I agree, it's already happening though. We already get targeted ads. When you're typing something into your phone and it comes up with a suggested sentence, it's usually quite what you wanted to say. It's already happening, it's already out there. So the question's going to be, do we as science agencies and warning kind of agencies, do we want to be part of that? Do we want to be accessing it? Should we be accessing it? Or should we be working with some of these tech giants who already have that information? So we need to have these partnership agreements in place with our next users. So that's the likes of media, but also these tech giants. We need data sharing agreements, funding agreements, intellectual property agreements, dealing with non-disclosure agreements, because we're already having to do that with some of them, and have very clear roles and responsibilities. So thinking back about sitting in your house with your phone and this message coming, and we've talked about who is giving this warning. We've been assuming that it's a science agency, but maybe it's not. Maybe it's Google or somebody else. How is it being generated? What's the data underpinning that? Whose hazard data and forecast data is this agency using? Is it the official science agency information, or is it coming from somewhere else, or have they got their own hazard forecast now? What exposure and vulnerability and risk tolerant information is underpinning that? And as warning researchers, what do we want to investigate right now to inform that? Because as I found in the National Transport Museum in London the other day, the future cannot be predicted, but futures can be invented, right? So what is our role here in making a future for warnings that is acceptable and actually empowers people to do the right action and try and mitigate some of this risk? Thanks very much for your attention.
Thank you, Sally. That was absolutely brilliant. So much to think about and to consider. And I think what Sally put together in the presentation is really kind of trying to draw the broader picture of what warnings are and how different elements interlink with each other and how they build on each other and what is the value of that and the evidence behind that. So that's such an important piece of work to be doing, and so we're really grateful that you've shared that with us. Before we move on to the panel, I just wondered if anyone in the room or online had any specific questions for Sally on her talk. Okay.
I can repeat the question.
Okay, perfect. Because then people may not necessarily be where you expect them to be, and then maybe different data sharing agreements if somebody's coming from overseas, so they may not be able to access that digital footprint. How, in this framework, would you stop people falling through the net, basically?
Yeah, good question. So it's about highly mobile people coming into a country, so tourists, for example, and how you might incorporate that sort of data in individual tailored warnings. So with things like cell phone tracking, it's all just going through the cell broadcast network anyway, as I understand it. And so that kind of data could be incorporated. But yeah, it would be reliant. I mean, if you think about New Zealand, it's so small. We don't really have too many agencies that would collect that kind of digital footprint data. It is all through the big global companies, is my understanding of it. And so I would think that people coming into the country are falling under the same net anyway. But you're always going to have individuals that are going to fall through that net, because there are many people, and I know some of them personally, who don't want to have a bar of putting their data out there in the world. You know, they would actively not sign up to anything online. They do not want the government to be accessing any of their information at all. And so those sort of people don't want to be involved in that kind of world. And so as a warning agency, we are still going to have to provide generic community-wide warnings, whether that's a siren or a loudspeaker or radio warnings or cell broadcast alerts that you can't opt out of. You know, you're still going to have that kind of generic warning from a responsible agency approach. So I don't think that that's the end of that. I think it's the addition of more individual warnings coming from agencies like corporations and things like that. Yeah, but it's a really good question, because I think at the end of the day, who are we trying to capture all these warnings? You know, are we trying to get the 80% of the population, or are we trying to get that other 20% as well that are already being missed, who already don't have cell phones and computers and are being missed? You know, how are we going to try and get to them? So this kind of forecast scenario approach is still missing those kind of people. Yeah, to come up with new ways, more community-based ways, I think. Chris?
Thank you, Sally. Sorry, thank you, Carina. Gosh, I was just a couple of things really. I was wondering, you've got all these plans here for example, targeted warnings. Has there been any chance to perhaps simulate this to see actually how people might behave if, say, for example, neighbours get different warnings? At that point, do they feel empowered, or might they feel perhaps uncertain why they get different warnings, or especially if you're under conditions of, conditions of stress, for example? I mean, is this sort of the next step, trying this out?
Yeah, no, it's not a plan. It's more of an idea about what the future might bring, and it definitely needs to be investigated. I think one of the key areas that we need to be looking into is the empowerment side of these kind of tailored warnings, to see how effective they are, or if they're actually detrimental, and we shouldn't be doing that at all. Yeah.
Thank you. You mentioned at the beginning talking to and involving the Indigenous communities as a source of information. How did you go about doing that? Because I think it's quite different in terms of some of the crowdsourcing you talked about from the public side of things. How did you work with those communities, and what kind of insights did you get from them?
Right, so this is not a research project, right? It's not saying what we've gone and done. It's saying what could be happening in the future. But the Indigenous knowledge side of things, there's a lot of participatory action research type methodologies out there that can be used that are very different in every single culture. And so it would be a matter of understanding what the appropriate methodology is in every country and with every culture within that country, and doing it at the ground level and doing it appropriately, basically. Yeah.
Great, thank you.
Great, one more question.
Thank you. I'm just wondering if do you ever account for anything like, and I'm just kind of making this up, I think, but like a warning fatigue. I think of like family members who may get like a hurricane warning and then nothing happens, and they think, okay, like how seriously do I need to take this, and how do you make sure that people remain motivated and take these, as the warnings become more accurate or more frequent, how do they take them as seriously as they should?
Yeah, it's a good question. So warning fatigue seems to be one of the things that I find physical scientists to be very worried about. They say that if we put out this warning too early or too uncertain, then it's not going to be good. We're going to lose all trust. What I understand from the research on warning fatigue is that hardly ever is the case. People are quite willing to accept uncertainty and the fact that it might not happen. But that needs to be investigated in different contexts a little bit more. So, at the start of the wildfire season, then people are more likely to respond anyway. By the end of the wildfire season, they've got warning fatigue and they're less likely to respond. But so it's all about timing and relativity and the experience of seeing what others have dealt with as well as yourself. So there's a feeling that impact-based warning is going to reduce warning fatigue. I'm skeptical about that, because I think if you've got more and more of this information coming, you're saying you're going to be impacted by this, and then it doesn't happen, maybe because you took a mitigation action, then you don't get impacted, and so I think there's actually the chance that it increases warning fatigue, and that's something that we need to look into a bit more there as well. So lots of uncertainties, but in general, particularly with hazard forecasts, I don't think we need to be too worried about warning fatigue.
Okay, we've got another question here from online.
Sally, this is from Robert online. Sally, great information as always. Your probabilistic information on the volcano unrest and eruption was very interesting. How do we deal with people seeing these very low numbers for an eruption and thus being concerned? P.S. Greetings from Iowa.
Thanks for the question. So low probabilities are a challenge to communicate for sure. So you have to be really, really careful that there might be let's say there's a 5% chance of an eruption at any volcano. To us, that might be incredibly high, right? Because we know what the consequences could be. But to a member of the public, they can be like, oh, it's only 5%, that's fine, I'm not worried about that at all, or even an emergency manager, for example. So people's understanding of what high and low probabilities are vary hugely. So there are different ways that you can communicate the probabilities. There are words that you can use that match people's understanding of what those probabilities mean. So for example, you might say there's a 25% chance of this size earthquake happening in this area in this certain amount of time. And then you'd put in brackets unlikely. Now, what is unlikely though? The word, when you hear 25%, you might think, yes, that means unlikely. But it's unlikely that we have this really big devastating earthquake. It doesn't work because it's not matched with the consequences very well. And so that's the problem with these small probabilities that we're trying to communicate. So we need to do some more research on when you're using these words with the numbers, like we do at GeoNet, in very devastating consequence kind of context. How can we still use those words, or what other words do we use instead? It can be to do with framing. So instead of saying it's extremely likely 1% that we're having this huge volcanic eruption, you might just say there is a very small chance that we are going to have this, and it's just a positive framing instead of the negative framing. So there's a whole world of research on communicating probabilities that we can draw on to do this, but there still is more research that needs to be done in a specific natural hazard context for those small probability but high impact events.
Oh, we've got another question coming online. Thank you to the lovely Amanda for reading these out.
This is from Milad. Sorry if I've mispronounced your name.
Thanks for the great lecture. Do you think we may need a mechanism for accountability of risk warning agencies in case of inaccuracy of warnings, such as overestimation of the cost of an action, poor estimation of exposure, probabilities, etc.?
Okay, so to do with liability and warnings. I think as soon as you have too much liability going on with warning agencies, you run the risk that those agencies no longer produce a warning, you know, because they're worried that they'll get it wrong or right. And so there's a real danger there that you have to give the scientists or the people in charge enough flexibility and freedom that they can do what is best with the information they've got at the time. You know, but of course there are boundaries, and people who do more politics and legal sort of research can comment on that kind of situation a whole lot better than I could, I think.
Okay, we have another one. Thank you, from online. It's great to see our online community participating. Thank you.
Yeah, thanks. This one's from Thomas. Thanks, Sally. How do we empirically investigate a topic like impact-based warning when it is often hypothetical and there is little empirical material?
Right, so the ways that I've done it, I have done it in a hypothetical example, using quantitative and statistics with some mathematician help. So as I was saying earlier, it's very difficult to do this in a real world situation. So some research that I've done is looking at when we had a real event come, right afterwards I surveyed the public to say what information did you see? You know, was it hazard, was it about impact, was it action information, etc. And I broke that down more. And then also looked at what were your perceptions and what did you do at various time frames. And that way you can kind of tear it apart a little bit more and see were the people that only received impact information or hazard information, etc., were they more likely or less likely to respond in certain ways. So that's the way that you can do it. But it's very difficult where in the current age people might receive all the information and very few people only saw hazard information, for example. So it's much more difficult to do that. So that would be in that very empirical, quantitative, statistical kind of way. The other way, of course, you can go and do it is go and talk to people and do a more qualitative, subjective way, which is fascinating because you get a lot more information than just a quantitative, statistical way. The quantitative way tells you how much, how often, how, you know, give me some numbers kind of thing, whereas the qualitative way is a lot more insightful as to why do people respond in this kind of way, what would have helped them, what stopped them from responding, and what you think is an appropriate way, and that kind of thing can be much more insightful as well. So it's a bit of a balanced approach, and depending on your research question, hopefully that answers the question.
Great, thank you. Yes, we have one last question on the floor. Thank you.
I was just having a thinking about timescales of warnings. Is there much known about the optimum time pre-hazard that a warning is most effective? I mean, the immediate answer is the sooner the better, for example, but I can also imagine the situation where if it's given too far ahead of time, then there's some complacency there, but there's also greater uncertainty in the hazard and the impact outcome as well. I was just wanting that over. I don't know whether that feeds into some of the things you'd be thinking about as well.
Yeah, it's a really good question. I haven't looked into that too much. My understanding is there is a little bit of concern about warning too far in advance, and that actually lowers people's willingness to act. But I can see also the other way around, where you hold off warning right until the last day, and then it's too late for a lot of people. Or the storm is meant to arrive on a Sunday. You're going away on the weekend, you're leaving on Friday, but you don't get warned that it's going to be a red warning until Saturday. It's too late now, you can't prepare your house even though you're going away, you know. So having that longer time period can be helpful for some people. And so I would think, yeah, you would give some more advanced warning, even if it's uncertain. So there's a conception that uncertainty shouldn't be communicated, or that low thing, you know, when there's high uncertainty, don't talk about it. But people can handle probabilities and uncertainty. We've proven that in our research. You know, a lot of people can. Sure, some people don't want it, but what about the people who do want it? You know, like, make it available. And so then people can use that information and prepare as much or as little as they think they need to. And we have to trust that, you know, empower the people to make what's right for them.
Great, thank you very much, Sally. And so now we'll move on to the panel discussion. So we'll just shift our way to the seats here. Great, thanks ever so much. So in this discussion, what we wanted to do was to sort of build on some of the points that Sally was talking about, bringing together some warning expertise. And as you can see, women seem to be quite strong in the expertise of warnings, as you can see. So I'm really delighted to have Dr. Mirianna Budimir, who's from Practical Action, and also Dr. Linda Speight, who's here from the University of Oxford. And then we've got Dr. Anawat Suppasri, who's on our screen, so we can see. Hello, thank you, joining us remotely today, who is an associate professor at Tohoku University's International Research Institute of Disaster Science, and is actually coming to visit us at UCL for a while. So I don't know if when you first answer your first question, it might be worth you just giving a brief introduction to yourself as you see fit to do so. But what I wanted to do was really start off by building on what Sally was talking about in terms of whether can you see that impact-based warnings could lead to better actions, so people actually doing things. So we'll start off with Linda, if that's okay. But yeah, do feel free to say a couple of words about yourself beforehand so that everyone can get to know one another. Thank you.
Excellent. Hello, everyone. My name is Dr. Linda Speight, and I am a lecturer at the University of Oxford. My background is in flood forecasting and warning, and I used to work operationally, delivering operational flood warnings, so I'm really motivated by the link between research and how we get research into applications. So that's where I'm coming from with this. So the question is, can impact-based warnings lead to better actions? This is a tricky question, I think, because it's quite difficult, because I think, yes, they can if they're targeted and they're understood by people and people realise, what those impacts might be. But we really don't have very good data on impacts. So I think this really limits our ability. And I come from kind of a modelling, meteorology, hydrology modelling background. And sometimes I wonder if we're diluting the skill of our models by trying to add the impact bit on. And there's two ways of looking at this. Some people are really keen that we can get over some of the uncertainties in the meteorological modelling by saying, but it doesn't matter quite where the rain's going to be because we know where the most people are. So if it goes there, then that's where the impacts are going to be bigger. So this is like the benefit of it. But then we also have the sense that we really don't need, when we think about the floods that we saw in Germany in 2021, people didn't really understand what the impact of that much water rushing down a catchment would be, and we weren't able to communicate that well in our warning. So I think they can, but I think we need more data to make them more targeted and better.
Excellent, thank you. Let's move on to Mirianna.
Hi, Mirianna Budimir. I'm the Senior Climate and Resilience Expert at Practical Action. We're an international development organisation. We work across Latin America, Africa and South Asia in many of the developing countries. And I work on the early warning system work that we do at community and national level, and then linking up with the global side of things. So similarly, yes, but. So I think impact-based warnings can be really useful in terms of avoiding the technical jargon, getting that people-centered information that is understandable for those who are trying to make those decisions on the ground. So yes, they can be really useful. But it really needs to be evidence-based and rigorous in the method that we're using in terms of figuring out what those impacts might be. And this then presents some problems, particularly in data poor regions where we don't really have that level of data to be able to provide that sort of insights into those impacts and what those impacts might be, and also in terms of understanding who those users might be as well. And so those impact-based warnings are most useful when we know that they are being developed evidence-based and specifically tailored to those user groups. And we really have a real struggle in many developing countries that data doesn't exist. And so I see there's efforts to try and do this in some contexts, and I feel like sometimes we might be jumping a couple of steps ahead and not doing this in a kind of a rigorous, considered way to make sure that we're providing the most appropriate information for those on the ground.
Great, thank you. Anawat, did you want to just give a little brief introduction and then let us know your thoughts? Thank you so much for joining us remotely today. Thank you.
Thank you. I'm sorry that I have to make myself joining online. Well, my family issue. Yes, so I'm doing. I'm civil engineering by training, and yeah. So in general, I'm doing things about tsunami, everything about tsunami, and yeah. Today I would like to share my experience about what we have done so far in Japan and also in Indonesia. So about the question, I think I would say stakeholder-based warning. So for example, in our community, or I think Sally just mentioned also in the last of her presentation that we talk about the probability, like let's say we will have this much of tsunami within how many years or many percentage, but the actual people or facilities or factories owner, they would like to even just like if this earthquake happen, where if the tsunami will reach that plant, something like that. So this kind of I mean, just the information that the scientific researcher or the government would like to release, and the information that the stakeholders or local people would like to receive is kind of different. So I think we have to think about more on the receiver side. This is my opinion. Thank you.
Thank you very much. That's really, really good. Did anyone want to comment on anything that anyone else has said before I go to Sally? Because I mean, I don't know if you have anything to add to this question.
Yeah, I think that was a really good point, because understanding what the stakeholders need hasn't really been done yet. And we're trying to produce these warnings, but there's been such little investigating about what the user needs actually are. I think maybe they're good. As I was kind of saying in my presentation, I think the biggest challenge is who the audience is, if it's for these stakeholders or in societal risk, or if it's for individual risk. So if you imagine, for example, you've got one person living, or a family living in a farm out in the countryside, and then a storm is going to pass over them, and the same storm is also going to pass over London. Using an impact-based warning approach, London would receive a red warning, you know, if it was a severe storm, but the person on the farm might get a yellow warning if they're lucky, because it takes into account the societal risk and the amount of impacts expected. But that family and the farm might, you know, they might be cut off. It could be lethal for them. But using the current impact-based warning kind of system, they don't receive that red warning, and that heads up to empower them to act or to evacuate or whatever. And so there's this huge danger with impact-based warnings that we're not empowering the individuals to act and to protect themselves. And so you're essentially taking out the element of exposure from the risk calculation. And if you do that, it's no longer a risk-based warning. It's hardly an impact-based warning. Really, it's just a hazard-based warning, and you're just telling people when a severe hazard's coming, which is what we already did in the first place. So I'm worried, and I'm skeptical that impact-based warnings are the answer. And I think we need to look a lot broader, look at the option of action-based warnings a lot more, to see should we be triggering warnings on the amount of action that an individual needs to take, and perhaps these impact forecasts only need to be given to stakeholders and not trickle all the way down to the public, perhaps, you know, to inform their decision making, but still provide these warnings to every single person so they can act. My controversial answer.
Thank you. Great. So in light of that, what do we think that actually the big critical gaps are that need to be filled in the context of warnings? Because I mean, Sally, you've already pointed out a huge amount of gaps in terms of action based, and it's kind of quite I don't want to use the word distressing, but kind of bizarre that, you know, we spend a lot of our time talking about how it's really important that people act on warnings and that we reach out to the last mile, and then, as I constantly say, we need to bring that to the first mile and interact people right from the start of that process. Yet that still seems very lacking within the literature and studies and having empirical research. So I just wondered if we could build on that in terms of what we think are the most critical research gaps, or gaps within your own experiences. So Anawat, I don't know if you want to start kicking us off and take us through some of those gaps.
Okay, so we go opposite. Opposite. Okay, as I start for it. Yes. So for tsunami perspectives, I would like to stress that well, let's say 80 or 90% of the world's tsunami was generated by earthquake, which we know quite a lot. But to give warning for non-seismic tsunami is still kind of challenging. And in the presentation, Sally mentioned, I remember she mentioned about the volcanic eruption or warnings, something like that. Like for example, last year we had a big eruption of Tonga, and the tsunami even reached well, of course, Tonga in Japan and caused some damage in Japan. We also at first the country didn't expect the damaging tsunami in Japan, and we have some sensor observation, and we could increase the warning, something like that. And like in 2018, there's two tsunami in Indonesia where the earthquake itself didn't generate the tsunami, but it generated landslide and then later on tsunami as well. So from my perspective, I think for research, we still need to understand more how this kind of non-seismic tsunami could be generated, rather than we know more about the classical earthquake types of tsunamis. So yeah, so this is kind of, once we understand more about how this kind of non-seismic tsunami could be happens, then we could increase the accuracy of the warning. Of course, in Japan, we have lots of sensor has been deployed after 2011 tsunami. So this could be also help for the monitoring issue for non-seismic tsunami, but for other countries, well, I think this kind of thing still undergoing and challenging. Thank you.
Thank you, Linda.
Hi, yeah, so to me, I think the most critical thing is linking back to kind of decision relevant skill assessment. So thinking about some of the things Sally was saying about trust in warnings, and are people going to respect the authority that's issued the warning and take action based on that? And I think that also links to the question that we had earlier about the lead time. You know, if we issue a warning 5 days in advance, is that useful to someone, or 2 days advance, or 1 day advance? And we're really good at looking at our forecast models and saying, yeah, we can, you know, predict there's going to be 10 millimeters of rainfall in the next 6 hours. Well, that's not actually going to cause a flood. So that's just how we're going to review the forecast, because that's the data we've got. So really thinking about how good are our models in the most extreme events and at the lead time that we expect people to take action based on them. And that's something that the humanitarian community, which Miranda can probably talk more about, has been really good at doing in their early action protocols, saying, you know, this is the tolerance we're prepared to accept. So this is how much uncertainty we're prepared to accept in this warning. And when it gets across this threshold, we know that sometimes we'll take action and nothing will happen, and sometimes we'll take action and that action will be essential to reduce the impacts. And being able to kind of really articulate and be really transparent that we've got the data to support that decision and we've properly made the decision, rather than being a bit of a knee-jerk reaction that, oh, something's happening, we need to do something about it, let's do it, and not really being transparent or understanding that. I think if we can get more evidence and more data on that, then that will help with some of these other aspects about warning fatigue and what lead time we should take action at.
Maybe that leads on to Mirianna, if you want to build on Linda's comments there.
Yeah, I mean, critical gaps, there's so many, unfortunately, but I mean, there's a lot of stuff that we need to be doing. The one or two things I wanted to pick up on are the more intangible things that kind of pull decision making together. So starting off from how people are making decisions and building back from that. So what is the information, what is the information that they need in that moment, but also what are the other enabling environments that they need, what are the other factors that affect, and we saw that in Sally's presentation, there are a lot of different factors that affect how people make decisions. And so how confident are we that we're doing everything in our power to build these early warning systems to make sure that we're targeting all of those elements? So do they receive the information? Do they understand the information? Can they act on it? What are the other barriers to people being able to reduce their risks to those immediate hazards? And that kind of then leads into, there's only so much early warnings can do. You know, these are, you know, ultimately kind of a short window of opportunity to really try and save lives and livelihoods. And so there's thinking about it from a bigger perspective and thinking, well, what are the other things that we need to be thinking about and building into the approaches that we're doing with early warning research, work, programming on the ground. There's also addressing people's resilience. So there's a great opportunities in terms of us providing information. Can that go beyond kind of the hazard immediate information? Can we be talking about making longer term decisions? Can we be talking about building better access to information, trusted networks, building that trust in authorities who have that information? What are the other elements that we can be building into our early warning systems to lead to that longer term resilience, to ultimately, you know, design it so that we are addressing all of the other components of risk, you know, using that work as an entry point. And I don't think there's a huge amount of work on that, and it'd be really, really great to kind of see the opportunities that window of that crisis window provides us to build in kind of longer term early warning resilience to disasters.
Brilliant, thank you. And Sally, did you have anything to add?
I thought that sounded really good. It was a really good answer. I'm trying to think of it from within a science agency. What do I think needs to be done? Because if we've got this early warnings for all initiative, and we have so much funding pouring into the physical science side, the monitoring and the satellites and the modeling, you know, there is so much that we need to do from a social science perspective as well. That's fundamental to providing effective early warnings. Unfortunately, the money does not come pouring into our side of things. So if we had the funding, we would be able to understand what makes a better warning, and then we can actually produce these more effective warnings. So if you're looking at it from a people perspective, it's understanding that community and local knowledge and Indigenous knowledge aspect side of things to understand what would be empowering for them, and the underpinning resilience factors. And then understanding more about the connection between the warnings and then the responses. So there's a lot of research that needs to be done there. How can we change the warning message, but also those underpinning thresholds? Are impact-based warnings more effective or not? Getting more research done on that. And then moving up that value chain to understand what are those underpinning data that are needed for impact forecasts. If we're going to be moving towards that, do we need that dynamic vulnerability and exposure data and the risk modeling? Or is it enough just to have a more subjective discussion approach? And then with the forecasts and the underpinning hazard models, looking more at aspects about resolution, for example, understanding how tailored and high resolution do we need these forecasts and warnings to be. So yeah, there's so many different things there. There's also, as well as warning fatigue, the communication of uncertainty and probability are always a really hot topic of needing to be filled, particularly for those low probability, high impact events. And really, what's the empowering? How can we get people as empowered as possible? Taking all of that into account.
Mirianna.
Yeah, I just wanted to tag on that. I think that the social science side of things is really essential. I like that kind of that you saying in terms of taking it back up the value chain. And I think that one of the elements that, and coming back to your point, Carina, about the first mile, I think when we're often talking about the first mile, we're still talking about getting the information to those people. That's not the first mile. The first mile is those people being able to make decisions that reduce their risks to those hazards. So if we're starting, a lot of the conversation with first mile is about disseminating the warnings or communicating the warnings to those people so that they can make decisions. And actually, I think there's an extra step in terms of the behavioral side of things, in terms of what is the change that we want to see, and the change that we want to see is people being able to reduce their risks. So starting from that's our first mile, and then working back. One of the steps back from that is that access to that information, but going back up that value chain from that first mile.
I think it's even further back than that. I think the first mile is people realizing they're at risk in the first place. So like a baseline understanding that they live in a flood risk area, or they live in an area that might be hit by tropical cyclones. I think most of the time we're talking about these conversations and we think everyone understands their risk, but that is not the case. Most people are receiving this information the first time in the warning, so therefore how will they know what to do with it? So I think there's a baseline education needed even before we get to the start of the road run.
I completely agree. And in many ways, the education could potentially address the sort of impact action gap a little bit more if like we actually understood a bit more about what the hazard is and what it might look like and what it might look in your school or your village's environment, you know, or your town's environment. That could be a certainly useful step. So it's really interesting. So we've sort of identified what the gaps are. So I kind of want to sort of, Sally was talking about what the future of warning is going to look like, and that's kind of quite a novel thing to be thinking about, because I think we spend a lot of our time grappling with what warning systems are rather than thinking about what we want them to be. So I just wondered, again, if we start with you, Anawat, as I appreciate that you might need to go soon, what do you think warnings of the future look like, or what would you like them to look like, and how do you think we're going to get them?
Yeah, well, before that, you guys just discussed about education. I would like to explain a little bit, share my experience about the 2013, the super typhoon Haiyan in the Philippines. I'm not sure if you are aware of that. The government actually released the warning of typhoon and the storm surge, but they precisely predict the exact time of landfall, but the local people didn't understand the meaning of storm surge. They just expect about the wind. So that's why they didn't expect such a large wave that could hit their towns. So I think, again, literacy, how people understand the warning message is quite important as well. I would like to support this idea. And for me, for engineering or scientific perspective, I would like to say that, well, in Japan, we have a lot of technology to support dissemination or warning as well. Of course, for flood or typhoon, we have more lead time in days or many hours to do simulation or disseminate the data or the result. But for tsunami, we talk about like 10 minutes or half an hour, which is quite short. And recently, using densely observation system, we're trying to get for the earthquake, we try to get such kind of earthquake source parameter or something like that as soon as we detect the ground shaking, and if we could using the high performance computer to simulate and make the hazard map, predicted hazard map, and if we could send this kind of information to local people before the actual tsunami arrives. This is how we in Japan, we are trying our best to do this kind of system and using mobile apps to support the evacuation route as well. Thank you.
Anna, can I just ask you on that? You're sending this great information to the people on the ground who are vulnerable to a tsunami, but how are they interpreting it? Is it because in Japan you are blessed with many disasters, so from a research perspective you get a lot of experience, or what is it that makes it that that's actually quite an effective tool in Japan specifically?
Yeah, so for the mobile app is still limited area where we have kind of pioneer research area, but even without the app, right now in Japan, the government can even send warning message to any mobile phone in specific disaster area. For example, if you are far from the sea, they will not send tsunami warning to that mobile phone. Or even though you are a foreigner, you are not buying phone from Japan, you somehow you can get that message as well. So they try to, yeah, as you mentioned, because we have many disaster in Japan, so they did their best and so that they can disseminate the information, and they give right, I would say, the local municipality to make decision, not from the central, because they believe that the local government, they know more about the locality than the central government. So this will make also different in terms of why this town announce a warning, why this town not. So it's really local, depends on the local government.
It's really good to hear that integration from technology right down to the local level. Mirianna, did you want to talk about what you would like to see warnings of the future to be?
Kind of a two-phase thing. One is that warnings are accessible to everyone, not just the majority. That it is really, there are mechanisms for the most vulnerable and the most marginalized to feed into their design and be able to receive and access and be able to take early actions. I would like them to be part of kind of everyday life, and that they're sustainable and institutionalized across the world, even in developing countries. And ultimately, I kind of want to get to a stage where we're no longer talking about it and we're no longer needed because we're doing it so well that there's nothing left to research. And even beyond that, I'm thinking it would be great if we could get to a stage, and I don't know whether this is even achievable, where they're just kind of a nice to have because we've reduced our risks to disasters so much that we don't need a window of opportunity to do anything, that we have systems in place, structures, we've been addressing the underlying vulnerabilities, the social inequalities that are driving the differentiated impacts to disasters, that actually these are just kind of the equivalent of making sure you pack your umbrella when you're going down to London today, for example, just in case it rains. And it's not a huge kind of life or death situation that we're having to kind of put these early warning systems in place, almost like a sticky bandage to just try and reduce the devastating impacts of them. So to be able to get there, it's a lot of hard work. I don't think we might be achieving this in any of our lifetimes, but it's a continuous research and then application and implementation and advocating to be able to design those early warning systems from, like we said before, the most vulnerable, from the first mile. We need the funding to implement it and build capacity in the context where they don't have the resources to actually be able to do this themselves. And it's really in that partnerships across different silos, across sectors, and also partnerships beyond our early warning community to the wider DRR and resilience communities and wider development sectors, so that we're integrating it as part of a puzzle piece that will be trying to tackle all of the issues that we face with disasters around the world.
Great, thank you. Linda.
Yeah, the notes that I wrote down about this question are very similar. So I've got part of integrated resilience plans, which I guess is the kind of the same thing. But the thing I've got down here that's different actually is that I think we need to accept that they're not perfect. I think as a research community, we get quite hung up on we need to have the perfect warning. It can't be wrong if we too many warnings out. I think we need to move past that and accept that, we're talking about these low likelihood, high impact events. Sometimes they'll happen, sometimes they won't. And that's okay. We can be more resilient if we know there's a chance they might happen and take preventative action accordingly. So I think if we could move away from the idea that our models aren't good enough and be more like, this is great information that we've had. It's so much better than we had 5 years ago, 10 years ago. With AI, it's going to be even better in the next few years. So stop worrying about it being wrong and think about how we can use it in the best possible way. And my other thing that I wrote down here was probably similar to Sally's talk, is that enabling personal responsibility. So encouraging people to not expect the authorities to help them in these situations so much, but to say, we've given you the best information. Now you have the resources because we've enabled you to reduce your vulnerabilities to this risk. We've given you bespoke information. You can now take action that's appropriate to you and make your own decisions about what level of risk you're prepared to accept.
Sally, do you have anything to add?
Yeah, I mean, I did, but yeah, I mean, what you guys were saying was spot on, I thought, and especially when you were saying at the end there was what I was going to say in terms of providing people with that specificable information. So the advice that is actually easy for them to do, it's low cost or they can afford it. It's not going too much out of their way to do it. They've got the resources and the community networks, etc., that help to do those actions. And I think for us to be able to, or somehow they're getting a warning and it has enough time for them to do those actions, and that they've got that information that they can use and they can understand and follow the advice to do whatever they need to do to get ready. And I think that would be the ideal warning, really, so that we're empowering them. But yeah, there's a lot more that goes on in the wider space, and I think land use policy and planning is a hugely important aspect that needs to be focused on and have a lot of funding and a lot of time, because that's what's saving people's lives. And the early warnings are just that band-aid at the end. So I think acknowledging that, but then also knowing how absolutely crucial it is that we have the best warning as possible, because at the moment we still have people living in floodplains and in these exposed and vulnerable locations, and so they do need warnings. And so it's sort of trying to make those warnings as best as we can.
Thank you. And so I guess our last question really pertains to what we mentioned a couple of times today, is the Early Warnings for All initiative, which was of course launched by the UN Secretary General Antonio Guterres last March in 2022, which was really to make sure that warnings are available for everyone in the world and can protect everyone globally. So I just wondered if perhaps each of you could comment on what you think the most important piece of knowledge from research is that can really make an impact on the Early Warnings for All initiative. What key thing do you sort of think an academic research project or practical research is needed? So Anawat, I'm going to go to you first again, and then I'll pass through.
Okay, thank you. Well, for research perspective, as I mentioned, I think from my perspective, we need to understand the mechanism of each, not only tsunami, but I mean in general, how each of the disaster has been generated and how it comes to our community. So that means once we can increase the accuracy, or we can give, I think some of you has mentioned about the word trust. We have to make sure and make confidence to our local resident that this warning message can be trust or is unbelievable. Well, in Japan, we have a kind of bad experience of 2011 that we largely underestimate the size of tsunami based on many constraints at that time. But after 10 years, we have improved a lot, and we have many sensors and observation system. So we could say that the warning for the next bigger one should be higher accuracy. But the problem is that, for example, probably could maybe only apply in Japan, because here, for example, one of my example I would like to share is we have kind of, for example, seawall, quite big, like 6-7 meters along the coast. That means it can also, disencourage people to evacuate, and even they receive the warning. Or on the other hand, for example, for us, even 1 meter of tsunami, as a government, they have to release the warning. If less than 1 meter, we say advisory. 1 meter above and below 3 meters, we say tsunami warning, and more than 3 meters, we say large tsunami warning, major tsunami warning. But the fact that we have the seawall 7 meters in front of us, so even just 1 meter, it should be fine. You will not overtop the seawall. You can continue your work, you continue your line production, but the word of warning will increase people feel worried about that. They would like to evacuate. So there are still some conflicts between the warnings criteria itself, the levels, and how the perception of local people or the facility or the stakeholders know that they would like to continue their business. So this is the thing that I think the research needs to be done in the future to solve this kind of conflicts between the physical defense, the warning levels, and the awareness of different types of stakeholders. Thank you.
Thank you. Sally.
Thanks. Okay, so early warnings for all. If there was one thing that we already know from the research that could be applied to make a difference, I think it's that warnings need to include the action advice. So many times we produce warnings from science agencies, and because of our roles and responsibilities, often we're not allowed to put in action information into there. So we're essentially giving a warning about something that's going to happen, but we're not giving any clue as to what people should do about it. Often that information does come separately from a different agency. So we need to have more coordination between those agencies so that when we're giving a warning about a hazard or its impacts, it comes with the action advice. And that action advice is easy to do, affordable, and actually empowers people.
Yeah. Thank you.
I was really struggling with this question because I think there's so many parts of a warning chain that we're all doing small bits of research to do, and I don't think there's one big thing. I think it's an incremental journey along the way, and every small bit is really important. So the thing that I thought, actually, from my own experience, is the most important thing is to include the researchers in the discussions about how you use the models, how you issue the forecasts, and that's been really valuable in some of the work that I've done on using global flood models to issue forecasts for tropical cyclones in Africa and Central America, and actually being able to say, okay, this isn't the best model because there's not a lot of data in this region, we don't really understand the impacts, we can't necessarily tell you the information that's relevant to decision makers, but because we've got the researchers there who have been developing that model, they understand its strengths and limitations, they can actually use that in a way that means we can still share useful information about the forecast. So I think rather than having one piece of knowledge, it's actually that researchers are really valuable in producing the forecasts and warnings in their own right.
Thank you. And Mirianna?
Agree with everything that everyone's already said. My slant on it is, and this knowledge already exists out there, is that reaching the majority is not good enough. It's good, but it's not good enough. If we're really trying to design early warnings for everyone, early warnings for all, then we need to be starting with those who are most vulnerable, most marginalised, who are going to be most severely affected by those disasters, and design their systems with them and for them in mind, and starting with how we understand gender, equity, social inequalities are leading to differences in access to information, in terms of different accesses to resources, in terms of their vulnerability profiles. And so there are a lot of the potential solutions that might work for the majority, and there's a lot of amazing digital solutions and digital technology, and AI is fantastic, and there's so many things that we can be doing that will be helping the majority. But there's a lot of people out there who are the most vulnerable, who do not have access to a mobile phone, and so therefore all of that work is not going to get down to them. So if we want to design it for everyone, for all, we have to start with those most vulnerable, most marginalised, and build it backwards rather than thinking of it as an afterthought. And it's considering, when are we done and when is it good enough? And realistically, if we're thinking about for everyone, it's when everyone can take early action to reduce their risks.
Great, thank you. Well, we've run out of time, so I guess I hope everyone's managed to take something from the day today. There's been a lot of great information. I know for me, I've had a number of little light bulb moments, which has been really nice and refreshing. So thank you. And I think today, in many ways, consolidates in my mind that actually we need lots of different tools, lots of different approaches to make sure that we get everyone, but that also requires coordination and discussion between those different groups, and that's what we hope early warnings for all will achieve, but obviously we want to achieve that aside from that as well. So what I wanted to do to wrap up is to say thank you so much to Dr. Taupō for giving us such a provocative and informative talk in terms of generating lots of discussion, to our panellist members, Linda, Speight, Mirianna Budimir and Anawat Suppasri. Thank you so much for joining us today. I'd also like to thank all the people who are our audience, both in person, which is really lovely to see people in real flesh in 3D, but also those of you that have joined online. We really appreciate you taking the time. Also to our fantastic filming team who's making this happen, so thank you very much. And also to Amanda, our administrator, who has done a lot of hard work to make this all work, and so we're very grateful to you all. Just wanted to flag two last things before you go. We've got a next event on the Friday the 26th of May, I believe it is, around air pollution. So please do take a look on our website for some upcoming information about that. And also recently we published a report with the GFDRR and World Bank looking at how we can design and implement inclusive warning system, which kind of builds a lot on what Mirianna was talking about, but all of us talking about how can we make those early warning systems inclusive for all. So please do take a look at our website and you can find a whole range of resources. So thanks for joining us, and we hope to see you next time. Thank you.